Once we have read the basic information on the program, we can proceed and use it. First, defining what is the rotation. In principle, the program allows you to include a full crop rotation with as many crops as you want. For instance, let's consider a rotation using wheat. We write and then we select wheat, durum wheat, click on plus to add it to the rotation with a yield of 3.5 tons per hectare, and we will rotate this wheat with sunflower for oil production. Click on plus with a yield of 2.5 tons per hectare. What are the meaning of the other variables in this table? First, the coefficient of variation that is presented here as percent. This is the ratio of the standard deviation of yield over the average yield. It is not important in the calculations, but might be useful in some situations that we will discuss in another tutorial. Then the harvest index is the ratio of yield over aerial biomass produced by the crop. We see default values for wheat or for sunflower. Then we have the percent of residues left in the field. We have a default for wheat of 10%, which means that we are selling the straw out of the farm. On the other hand, for sunflower, we are leaving all the residues in the field. Then N, P, and K are the concentrations of nitrogen, phosphorus, and potassium in the harvested part, therefore in the grains of wheat or the seeds of sunflower. Cubic meters per hectare is the amount of irrigation applied to the crop. As we are rainfed conditions, this value is 0. Then N max is the percent of total nitrogen that is applied before planting. In this case, we have set a value of 40. Finally, burning residues indicate this. This would be click if we are burning the residues that are left in the field. If we left all the straw of wheat in the field, this value would be 100. Now, the latitude and longitude define our geographical location. These coordinates correspond to Cordoba in Spain, and they are used for the program to determine what is the average rainfall for all months in the year in order to calculate the leaching index. We have already commented that the water supply is rain-fed, and here in milligrams of nitrogen, nitrogen as nitrate per liter would be the concentration of nitrogen in irrigation water. We have 0 because we are not applying irrigation. The soil type might be changed. Let's say for a clay soil, if we change the soil type, we change automatically the default cation exchange capacity and also the soil hydrological group. If we move to clay, then the cation exchange capacity and the hydrological group are changed accordingly. We have click tillage if we are applying tillage. Then, to the left, we see soil analytical data in special phosphorus. We leave at 0 if no information is available. The same goes for potassium in the soil. For phosphorus, we could use different methods for the analysis of soil phosphorus. In this case is Olsen, and this is the soil organic matter as percent, the cation exchange capacity that could be changed if we had a measurement, and finally the pH. Then we had the possible strategies for phosphorus and potassium fertilization. The first would be the sufficiency strategy. That means that only when the soil analysis of phosphorus or potassium are below threshold levels, we will apply fertilizer. Otherwise, we don't apply. The build-up and maintenance means that we first correct the fertility of the soil, we increase to values above the threshold, and then for maintenance we supply back the nutrients exported from the farm. Finally, if soil analyses are not available, we can only select maintenance, which means restoring the nutrients that are exported from the farm. If we don't have no data on P or K, we try any alternative, the program forces us to go to maintenance because soil analysis is not available. In other words, to use any of the three first strategies, we need to input data for soil analysis.